So hello everybody, so my name is Jerome Vienne. I am a postdoctoral researcher working at the Ohio State University, as Thurston introduced. I am working in the network-based computing lab from Professor D.K. Panda. And I will introduce you today the work that I did with Jitong Chen, Vashu Raman, Nusrat Islam, Hari Subraboni, and the Professor D.K. Panda. So my presentation will be in 4 parts. The first part, I will introduce you the ConnectX 3 that has been introduced recently, and the network protocol stack that we use for our analysis. Then I will quickly introduce the cloud computing application, especially the middleware, because I'm pretty sure that everybody knows about HPC, but not necessarily cloud computing. And after, I will talk about our performance analysis and evaluation before to do the conclusion. So, as you know, commodity clusters continue to be very popular in HPC and clouds. And HPC application and cloud computing middleware like Hadoop have varying communication and computation characteristics. Recently, the PCIe Gen3 interface has been released, and this interface allows to deliver a speed up to 128 gigabit per second. And we have also some high-performance interconnect that are now capable to deliver a speed up to 54 gigabit per second. And one of the interconnect is a new Mellanox ConnectX 3 FDR, RoCE 14 gigabit Ethernet. So let's talk about the network protocol stack. The network protocol stack could be divided into 2 categories: socket-based and verbs-based. If you use the sockets interface with the high-speed Ethernet interconnect, you will use a generic, I don't know if we can see here, the classical Ethernet driver. When if you use InfiniBand interconnect, you will use IB over IP. And with the verbs interface, if you use an high-speed interconnect, you will use RoCE. When with IB card, you will use IB verbs. So for the people, if you don't know RoCE, so RoCE is a new protocol that allows the RDMA of InfiniBand to run over Ethernet. And the 2 Mellanox cards, ConnectX 2 and ConnectX 3, are able to use all this protocol, but of course at different speed, as you can see. Knowing that, we had the following questions. How much benefit can the user of the HPC cloud installation hope to see by utilizing this new HCA compared to the IBQDR and RoCE 10GigE interconnect? And how does InfiniBand compare with RoCE in terms of performance? So let's talk quickly about the cloud computing application. So as you know, cloud computing economy are gaining significant momentum and popularity. But cloud computing middleware requires the highest performance and reliability available. Hadoop is one of the most popular frameworks for running application on large clusters. And in our study, we use 2 major components of Hadoop, HDFS and HBase. HDFS means Hadoop Distributed File System, and it's the underlying file system for Hadoop framework. HDFS is designed for storing very large files on clusters of commodity hardware, and inside the HDFS cluster you have 2 main types of nodes: name nodes that are responsible for storing and managing the metadata, and the data nodes that act as storage for HDFS file. The HDFS files are usually divided into fixed size blocks of 64 megabytes and stored at independent unit. And of course, each block is replicated to multiple data nodes to provide this fault tolerance and availability. HBase is part of the Hadoop project, and it's a Java-based database, and it runs on top of the Hadoop framework, and it's used to host a very large table with many million of entries. HBase is also able to provide a capability similar to Google's Big Table. For our HBase 2D, we use also YCSB as a workload. YCSB, so Yahoo Cloud Serving Benchmark, facilitates the performance comparison of different K value pair and cloud data serving system. And this benchmark defines a core set of benchmarks, of course, to analyze different systems. So now let's talk about the performance analysis and evaluation. For our evaluation, we use 4 nodes. Inside each node there was 2 Sandy Bridge, providing us 16 cores per node, 32 GB of memory, and we had also 1 PCIe Gen3, and we use Mellanox OFED version 1.5.3. And at the network level, we use a 32-port Mellanox FDR. And for our experiment, we switch between the ConnectX QDR 10GigE and the ConnectX 3 FDR 40GigE. This is a different performance result that we will provide. First, I will talk about network level performance. We will look the latency and the bandwidth. After, I will go at a higher level using showing the MPI level performance for point-to-point, MPI Collective, and I will show at the application level using the NAS parallel benchmark. And at the end, we will see the result for the cloud computing middleware using HDFS write, testing HDFS write with Testbed SEO and HBase, and we will look at the throughput of HBase Get and Put. So when we look at the latency, so the x-axis represents the message size and the y-axis represents the latency, we can clearly see that FDR is providing the best latency. And between 40GigE RoCE and IBFDR, we can see that there is 52% of difference. And for the QDR, we see also that QDR latency is a bit higher than FDR, but it's still better than 14GigE. At the bandwidth level, we see something a bit different. Here, as we can see here, the bandwidth of RoCE 14GigE is much more better than the bandwidth of IB QDR. The reason is very simple. It's due to the network level encoding done by ConnectX 2 card and ConnectX 3 card. On the ConnectX 2, the encoding is 810. It means that for 10 bytes sent, there is 8 bytes of data. But for ConnectX 3, the ratio is 64-66. It means that for 66 bits sent, there is 64 bit of data. Now, let's take a look at the MPI evaluation. To do our MPI evaluation, we use MVAPICH2. So MVAPICH2 is a very popular high-performance MPI library that is used by many clusters. Some of the clusters are listed here: Pleiad, Tsubame, and Ranger. And so using MVAPICH2 and the OSU benchmark, we evaluate the point-to-point MPI latency. Here again, we can see that IBFDR is providing the best performance, but the difference at the latency level between RoCE 14GigE and IBQDR is much smaller, but IBQDR is still providing the best performance. And as before, RoCE 10GigE is providing the worst latency. Bandwidth-wise, we can see exactly the same performance that we saw at the network level. It means that we still have the RoCE 10GigE and FDR that are performing better than IBQDR and 10GigE. RoCE 10GigE. Looking at the collective, using the graph present here, it's a scatter result for large messages using OSU scatter. We can still see here that IBFDR is providing the best performance, following by RoCE 14GigE and IBQDR. At the application, to test the application, we use the NAS parallel benchmark class C. So what are the NAS parallel benchmarks? These benchmarks are designed to mimic computation and data movement in CFD application. So for this experiment, we use 4 benchmarks, FT and IS, that are known to be communication bound, and MG and BT, that are computation bound. So if we look first at the result of MG and BT, we can see that between the different networks, there is no big difference, except, of course, for RoCE 10GigE, because this network is providing, is slowing the communication, leading giving a higher execution time. But except for 10GigE, we have something very similar. When you look at FT and IS, we can see if we compare the IBQDR and IBFDR, we can see that for FT, FDR is 12% better for FT, and for IS, FDR is 20% better. On the RoCE side, we can see that 14GigE is 32% better, and for IS, 14GigE is 46% better. So now let's take a look at the cloud computing testing. So for the evaluation, we use Testbed. So Testbed is a file system benchmark to measure the I/O performance of HDFS. We use HDFS write because it's more network sensitive compared to HDFS read. And in this sequential write, each map task opens a file and writes specific amount of data to the file. And we have at the end a single reduced task that aggregates the result of all the map tasks. So how was our protocol? First, we start 2 map tasks, each writing a file to 3 data nodes. Then we vary the file size from 1 GB to 10 GB, and we measure the throughput of sequential write reported by Testbed. So on the x-axis, we can see the file system size. On the y-axis, we can see the throughput. So for 1 and 3 GB, we can see that we have a very high throughput compared to 5, 7, and 9 GB. This performance issue is because we are only using 3 data nodes, and when we reach a file size of 5 GB, we have a lot of I/O between the 3 data nodes. That is reducing, of course, the performance. But globally, due to its high bandwidth of IP over IBFDR system, the sequential write is providing a better throughput for the system size compared to IP over IBQDR. Concerning the socket at the sockets level, we can see that the throughput of sequential write is improved by 31% using 14GigE compared to 10GigE. So for the HBase evaluation, we use, as I mentioned previously, YCSB, and we perform 3 different operations: 100% get, 100% put, and 50% get and 50% put. The HBase case operation, of course, requires a less network communications compared to the HBase put that create more traffic. And the mix get and put generate also some network traffic. For this evaluation, we use 3 region servers. The region server communicates with the master, so HDFS name node, and the HBase client through the interconnect. And usually, region servers are configured to reside in the same node as HDFS data node to improve data locality. And for this workload, we use 320,000 records to be inserted to be answered and read from HBase. So, if we look at these results, we can see that the IB over IB FDR is providing always the best. IB over IP with FDR is providing the best performance. We can see 9% benefit for the get-put mix. We have up to 10% benefit for the IP over IB FDR with 100% put. And overall, IP over IB FDR is 25% better than the 40GigE. So to provide a global overview of the different results, we can see that at the network level, the IB FDR is providing, for all the different things, at the network level, the IB FDR is providing the best performance compared to the RoCE 14GigE. At the performance for the HPC application, IB FDR is still providing the best performance, following by the RoCE 14GigE. But for the cloud computing, the IB over IP FDR is providing the best performance, following by the IP over IB QDR. The reason of this difference is because we are thinking that the Mellanox OFED is optimized and provides better performance for QDR with IB over IP. So let's talk now about the conclusion. We carry out a comprehensive performance evaluation for the different modes of communication. We saw that the latest InfiniBand FDR interconnect is providing the best performance. At the network level and HPC application level, we saw that RoCE 14GigE is performing better than the IB QDR. And at the cloud computing level, we saw that IB over IP QDR performance are better than the RoCE 14GigE. And that's all.